Ever wondered why flipping a switch lights up your room or how your phone comes to life when you press the power button? It's all about electricity. Electricity, you see, is a form of energy that comes into play when there are charged particles. These particles are known as electrons. When these electrons get a bit adventurous and decide to move from one atom to another, it creates something we call an electric current. So, electricity is essentially all about the movement of electrons. But what makes these electrons move? The answer is voltage. Voltage is the unseen force that propels electrons through a conductor. Picture it like the pressure in a water pipe. This pressure pushes water along the pipe, overcoming any resistance it encounters. Similarly, voltage pushes electrons, driving them from atom to atom, creating what we know as electric current. Without voltage, there would be no movement of electrons, and hence no electricity. It's the essential push that brings the power of electricity to life. Now that we have moving electrons and voltage, where do these electrons move? They move through conductors in a circuit. Let's break this down. First up, conductors. These are materials that allow electrons to flow easily. Think of them as the highway for electrons. Common conductors include metals like copper and aluminum because they have loose electrons that are free to move. Now let's talk circuits. An electric circuit is pretty much a well-planned route for these electrons. It provides a path, typically consisting of a power source, like a battery or a generator, conductive wires, and devices that use the electrical energy. The power source provides the voltage, pushing the electrons, which then move through the conductive wires and power up our devices, be it a light bulb, a motor, or your favorite gadget. So, a circuit is the playground where the magic of electricity happens. However, not all materials play nice with electricity. Some offer resistance. Now, what exactly does that mean? Resistance, in terms of electricity, is the opposition to the flow of electric current. Think of it like trying to jog through water. The water slows you down, making it harder to move. That's resistance. Just as each material has its own unique characteristics, they also have their own resistance levels. For instance, metals like copper and aluminum, known as conductors, have low resistance, allowing electricity to flow through them with ease. On the flip side, materials like rubber and glass, known as insulators, resist the flow of electricity, making them ideal for things like the protective coating on wires. Now let's bring in a key player in understanding electricity: Ohm's law. Named after the German physicist Georg Simon Ohm, this law is a fundamental principle in the world of electricity. It tells us that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance between them. In simpler terms, Ohm's law is expressed as I equals V divided by R, where I is the current in amperes, V is the voltage in volts, and R is the resistance in ohms. So, the higher the voltage, the higher the current, but the higher the resistance, the lower the current. Ohm's law is a fundamental principle that governs the flow of electricity. So, we've learned the basics of electricity, but why does it matter? Well, let's start with power generation. Electric current is generated at power plants through various means, such as burning fossil fuels, nuclear reactions, or renewable sources like wind and solar. This electricity is then transmitted through power lines to our homes, businesses, and industries. Now consider your everyday devices like smartphones, computers, even your television. Can you imagine a day without them? Not very likely. And it's the electric current that powers the circuits making these devices work. And what about transportation? Electric current powers the motors in electric vehicles, a trend that's gaining steam due to environmental concerns and advancements in battery technology. When the sun goes down, we don't stop. Whether it's traditional incandescent bulbs, fluorescent tubes, or modern LED lights, electric current powers the illumination that brightens our nights. And it's not just about lighting and gadgets. Electric current is also used for heating and cooling. Think about your electric stove, your heater in winter, your air conditioner in summer, or your refrigerator keeping your food fresh. Finally, let's not forget about industrial applications. Electric current is crucial in various industrial processes such as manufacturing, refining, and chemical processing. So there you have it. From lighting up our homes to powering industries, electricity is truly the lifeblood of modern society.